First is empty set or void set, just explained. Let A be a set, then empty set is a subset of A cross A. I told you, here in 12th class we are generally studying the relation on a set. So it is a subset of A cross A. So empty set is a subset of A cross A, and so it is a relation on A. This relation is called the void or empty relation. Next is a universal relation. I told you, A cross A is a subset of A cross A itself. Therefore, A cross A is also a relation on A. That relation is known as the universal relation. So A is a set, then A cross A is a subset of A cross A, and so it is a relation on A. This relation is called the universal relation on the set A. Dear children, these two relations, empty relation and universal relation, these two relations are known as trivial relations. So if we got a set, then without any difficulty we can write two relations on that set. Empty relation, other is universal relation. Now I am here going to discuss another relation that is called the identity relation. Let A be a non-empty set, then a relation IA, generally in identity relation is denoted by capital I, and it is defined on the set A, so we are writing as IA. Is set of all ordered pair AA such that A element of A on A is called the identity relation on A. So identity relation is the set of all elements that is related to itself. That is called the identity relation. I'll give you an example. Let us consider a set. Suppose a set A equal to set of all ordered pair. Not ordered pair. I am taking a set, not writing the relation. Set 1, 2, 3. Now I am defining a relation here, R1. R1, a relation. And this relation is a ordered pair 1, 1, comma, ordered pair 2, 2, comma, ordered pair 3, 3. Clearly, R1 is a subset of A cross A, so R1 is a relation. This is called identity relation. This is identity relation. Identity relation on A. Now I am writing another relation. Suppose I am writing as a relation, I am writing R2. R2 is equal to the same way ordered pair 1, 1, ordered pair 2, 2, ordered pair 3, 3, and also ordered pair 1, 2, because one here in this set 1 is related to 2, and I am writing ordered pair 2, 3 also. It means that 2 is related to 2 is related to 3. So we are having two relations, R1 and R2. R1 is that every element is related to itself only. And here every element is related to itself as well as it is related to some other elements also. So this is not an identity relation. This is identity relation. Here it is, this relation, this R2 is not not an identity relation. The reason? For identity relation, the element should be related to itself only. So, but in this case, in R2, some elements are related to some other elements, so it is not an identity relation. I think it's clear now. Next, we have to discuss an important relation that is called a reflexive relation. What is a reflexive relation? A relation on a set A is said to be reflexive if every element of A is related to itself. If every element of A is related to itself, then the relation is called a reflexive relation. Thus, R is reflexive implies and implied by ordered where AA element of R for all A element of capital A, the set A. Dear children, please note that every identity relation is reflexive, but the converse is not true. But the converse is not true. We have seen the previous case. R1 is an identity. I shall repeat it once again. Suppose A is equal to set A is equal to set 1, 2, 3. I'm taking R1 is equal to ordered where 1, 1. That is the 1 is related to 1. Ordered where 2, 2. Ordered where 3, 3. Now R1 is an identity relation as well as R1 is a reflexive also. Why? Because every element is related to itself. 1, 2, 3 are elements of A. Now I am taking the next relation R2. R2 is equal to set of all ordered where 1, 1, comma 2, 2, comma 3, 3. So 1 is related to 1, 2 is related to 2, 3 is related to 3. Then 2, 3 means 2 is related to 3, 3 is related to 1. See, in this case, R1 is a reflexive as well as identity. But in R2, it is not identity. Why? Because all elements are related to itself, but 2 is related to 3 also and 3 is related to 1. So in this case, in the second case R2, it is reflexive but not identity. So we can conclude that every identity relation is reflexive, but every reflexive relation is not an identity relation. Okay, it's clear now. Now, next is a symmetric relation. Now, what is a symmetric relation? Let us check. A relation R on a set A is said to be symmetric relation if and only if ordered where AB element of R implies ordered where BA element of R for all A and B element of the set A. That is, if A is related to B, then B should be related to A. If it's so, the relation R is called a symmetric relation. That is, ARB implies BRA for all A, B element of the set A. That is, A is related to B implies B is related to A. Let us have an example, a simple example. So I am taking the set A is equal to set of all elements, that is P, Q, R. I am taking P, Q, R. Suppose R1 is the relation R is defined as R is equal to, I am taking P is related to P, suppose P is related to P. Q is related to R, comma, Q is related to Q, R related to Q, P related to Q, and Q related to P. Check whether the relation R is reflexive. P is related to P, agreed. Okay, Q is related to Q, that also correct. Whether R is related to R here? No, R is not related here. So, the relation R is not reflexive. Now to check whether it is symmetric. Symmetric means if A is related to B, then B should related to A. Of course, Q is related to R. R is related to Q. Agreed. P is related to Q. Q is related to P. Okay. So, the conditions for the symmetricity is true here. Hence, this relation R is a symmetric relation. This is not reflexive, but it is symmetric. Okay? Now, let us discuss a next type of relation, and that is called the transitive relation. Transitive relation. Let A be any set, any non-empty set, of course. A relation R on A is said to be a transitive relation if and only if ordered by AB element of R and ordered by BC element of R, the relation R implies ordered by AC element of R for all A, B, C element of the set A. That is, A is related to B and B is related to C, implies A is related to C. You please note. A is related to B. A is related to B and B is related to C. If both are there, then A should related to C also. Then the relation is said to be a transitive relation. We may have one example. Suppose A is equal to set 1, 2, 3, 4. Suppose a relation R is defined as R is equal to set 1 is related to 1. 1 is related to 1. 2 is related to 2. Suppose 3 is related to 2. 2 is related to 3. And I am taking 2 is related to 4 also. Let us see. Now 1 related to 1, 2 related to 2, 3 is related to 2, 2 is related to 3. Then to get it is a transitive, 3 should be related to 3 also. So I have to write 3 related to 3. 3 related to 3. Then 2 is related to 2, 2 is related to 4. So again 2 is related to 4 related to. Now 3 is related to 3, 3 is related to 2. So 3 should be related to 2. So again 2 is related to 3, 3 is related to 3. So 2 is related to 3. So the post conditions for the transitivity is clear right here. So this relation is transitive. Is it reflexive? 1 is related to 1, okay. 2 is related to 2. 3 is related to 3. But 4 is not related to 4 under this relation. So it is not a reflexive. Is it symmetric? 3 is related to 2. So 2 is related to 3. Okay. 2 is related to 4. But 4 is not related to 2. So it is not symmetric. So this relation is a transitive only. Okay. Now let us discuss another important relation, important type of relation. Now, equivalence relation. A relation on a set A is said to be an equivalence relation on A if and only if it is reflexive. That is, every element of A is related to itself, ordered by A element of R, for all A element of A. Second condition is symmetric. That is, A element of ordered by AB element of R implies ordered by BA element of R, for all A and B elements of the set A. And the third condition is transitive. That is, AB element of ordered by AB element of R ordered by BC element of R implies ordered by AC element of R, for all A, B, C element of the set A. If all the three conditions are satisfied, then the relation R is said to be an equivalence relation.